Good morning. I'd like to welcome you to Broadcast to Post, Keycode Media's series hosting industry professionals discussing the broadcast, live production, and post technology topics that you care about. I'm your host, Steve Dupay, Senior Broadcast Account Manager here at Keycode Media. Today's topic, SMPTE 2110, How to Deploy an IP-Based Infrastructure. IP video for broadcast has transitioned from a novelty to a necessity, as broadcasters everywhere looked for a way to reduce system connectivity complexity by reliably and cost-effectively transporting high bitrate media across an IP-based network and through the public internet while simultaneously riding the wave of IP technology advancement and cost reduction. SMPTE 2110 is the accredited standard for achieving the same reliability and interoperability that the industry attained with SDI signals over coax and fiber, but with the added advantages of bidirectional communication and data recovery through a packetized stream over standard IP networking. Why is Keycode Media discussing IP workflows? We have been the preferred dealer and systems integrator for installing and supporting large and small broadcast studios, mobile truck, and fixed facilities, as well as flypack and remote production systems. Our success in designing, installing, and supporting broadcast systems comes from our eclectic and experienced team that successfully installs a broad range of audiovisual, broadcast, and post-production equipment solutions. Combined with our 24/7 KTC aftermarket support plans and certified training, your team has everything it needs to implement your ideal system with ease. Lastly, our Keycode Education School provides industry-recognized certification. And if you work for a qualified ETP media company, your entire staff can get trained for free. We are just about to launch a new Engineer Track certification program, so contact us or subscribe to our newsletter to learn more about when that becomes available. Before we get to our expert panel discussion, we need to spend a few minutes defining IP video protocols and the various SMPTE standards. When it comes to IP video protocols, it's a lot like video and image file types. There are several protocols and methodologies available, each with their own strengths. Let's briefly review some of these others before we get into 2110. NDI. NDI comes in two flavors, compressed NDI-HX and full NDI. NDI-HX is a lot like H.264. Its transmission bandwidth is adjustable, with 1080p 60 video defaulting to 10 megabits per second. Full NDI is an I-frame interframe compression scheme. During the transmission process, full NDI consumes a certain bandwidth, HD needing 90 to 180 megabits per second, and 4K with 200 to 300 megabits required. With NDI transmission, we recommend a gigabit network, which is suitable for applications that require high image quality, such as program production. There's a full suite of free, super helpful NDI tools that can do everything from a screen capture on a computer or a device on the network to converting multiple guests from a Microsoft Teams call into unique inputs on your video switcher. Delay for NDI on a local network is typically less than 100 milliseconds or about 1 to 3 frames. NDI is also best suited for local area networks, although there are applications that can help broadcast NDI over the internet. SRT. SRT is a transmission protocol based on the H.264, H.265 compression scheme. The focus here is on delivering high-quality video. SRT's anti-packet loss mechanism is an ARQ, that is, an automatic repeat request error correction mechanism, removing jitter or packet drops that can sometimes happen to video. Delay for point-to-point transmission is under 1 second. SRT is made to transmit signals over the internet, but it is important to note that SRT transmission applications require a fixed public IP address on either the sender or the receiver. RIST. The Reliable Internet Stream Transport Protocol is similar to SRT, containing a special packet loss algorithm that reduces error, providing a high quality and highly reliable broadcast stream. RIST is unique when it comes to protection. RIST SafeLink protects live video and audio over unsecured networks. There is also RTMP streaming, which is arguably on its way out, but is used heavily by Flash and mobile iOS and Android streaming apps, and Dante and AES-67 for audio, and many more that we're not listing here. And that's the point. With all these IP cars driving fast on the virtual highway, we need to create standards and best practices to keep each video or audio stream in its lane. The SMPTE 2110 suite of standards is helping to drive the development of IP video flows in a responsible way that benefits the industry. Let's take a look at the types of standards available so far. SMPTE 21-10-20-30 address system concerns and uncompressed video and audio streams. SMPTE 2110-21 specifies traffic shaping and delivery timing of uncompressed video. SMPTE 2110-31 specifies the real-time RTP-based transport of AES-3 signals over IP networks, reference to a network clock. SMPTE 2110-40 maps ancillary data packets as defined in SMPTE 291-1 into RTP, that is real-time transport protocol packets, that are transported via UDP IP and enables those packets to be moved synchronously with associated video and audio essence streams. Now that we've defined the basic terms of IP video environments, let's get into our main panel discussion. Our panel today will be discussing the implementation, design, and install components involved in building a SMPTE 2110 IP-based facility. We're going to get into the nitty-gritty of hardware, cabling, glue, or converters, and solutions that are necessary when building out a new facility. We'll also cover some other hot topics and signal flow considerations. Joining us today are literally some of the best people in the industry to answer these questions. Ciro, Executive Vice President of Engineering at Cobalt Digital, a consulting professor at Stanford University and the holder of 7 patents. Robert Erickson, Strategic Account Manager for Sports and Venues at Grass Valley, and a former Director of Advanced Technology. John Mailhot, CTO and Director of Product Management, Infrastructure, and Networking at Imagine Communications, a SMPTE Fellow and Chairman of the SMPTE 2110 Committee. Thomas Edwards, Principal Solutions Architect and Evangelist, Amazon Web Services, and a former Vice President of Engineering and Development at Fox and Disney for over 12 years. Thomas is also a SMPTE Fellow. This first question I'd like to direct to Ciro. Ciro, all of this 2110 video over IP is for use in the studio where you control the infrastructure. But what do you need to do when you need to go out of the building, even over the internet?
Yes, thank you for that. So there's all the 2110 work, but that's not the only video over IP work. I like to talk about that because I'm involved with something called RIST, Reliable Internet Stream Transport. And we have here with us the guy who actually invented the acronym, Mr. Edwards. And that was an effort to basically, I'm not allowed to use the word standardized, but I'm going to use it anyway because it's not a standard. The communication, reliable low latency communication over the internet. So you have the 2110, which is the pristine video going uncompressed inside your network and your local environment, and that costs you gigabits and gigabits per second. But if you're going to go over the internet, yeah, it's getting there. You can sometimes get very high bit rates, but the problem there is packet loss. So the thing I want to raise here is the existence of this video services forum specification. We got together a number of vendors or people who I like to say hundreds of many years of experience combined. None of us is 100 years old, but hundreds of many years of experience combined to create this specification so that you can do exactly the same thing you're doing with the 2110 inside your facility. You can go out and pick best of class for whatever it is that you are doing. You're not locked into some proprietary vendor solution. And you don't have to make any compromises on quality. It is best of class, and it follows whatever standards are available for everything. It's kind of what Mr. Ackerman's, our AG chairman, calls the Lego approach. You take the pieces that fit, and then you like design the glue around that. So that's what I wanted to talk about.
Excellent. I appreciate that. That's great information. Robert, could you maybe talk to us a little bit about building in native 2110 support into your products and how that's going and what the future of compressed workflows in native IP products looks like?
Well, that's the tough part, right? I mean, what's the point of doing IP workflows if your devices still need gateways or anything like that? So obviously the big focus has to be on making all of your devices native IP. For Grass Valley, it's kind of a big thing because we have cameras and switchers and infrastructure and replay and all this. So it ends up being a significant amount of work, but it's work well worth it. Because once you get to the point where your cameras are nothing but an IP connection, which they are, you plug them in the network and you have your transport sorted. Same with switchers and things like that. But just getting 2110-20, uncompressed workflows isn't where we need to stop. If there's anything that we've realized over the past year and a half, is the ability to use IP connections and IP resources in a WAN environment, or in a cloud-based environment, or a public or private data center environment. So for us, the next big jump is getting compressed support native into the product. Because it's pretty easy now for everybody to get 2110-20 and -30 and all that kind of stuff in the products. But making that next jump, 2110-22 is all about compressed workflows, right? So how can we build cameras with native JPEG XS into the camera heads? Well, we've done that. All of our up-down cross converters now support native JPEG XS. Our multi-viewers all support JPEG XS. Things along those lines is how do you give those workflow tools to our customers? Because that's what it's all about. 2110-20 was just about not necessarily matching SDI workflows, but it was getting some of the workflows that we had in SDI migrated to IP, just larger scale, more flexibility, so forth. But if you really want to unlock the types of workflows our customers want to do, you can't just keep doing uncompressed. You have to be able to add more solutions to that. So being able to add things like JPEG XS natively into your products, things where you don't need external conversion or cards or anything like that to do it, is really the next step to give our customers those tools so they can do the workflows that get the job done for them. So it's tough to do. Just going IP takes more power into the products in terms of power draw and heat and things like that. And then making the next jump into compression, JPEG XS, requires yet again more power, more thermal, stuff like that. So there's a lot of challenges to it, but in the end, the outcome is well worth it.
That's excellent. And leads actually to my next question for Thomas. Let's talk a little bit about ST2110-22 with JPEG XS and moving low latency media from ground to cloud and back. Also, where is uncompressed ST2110-2 on the roadmap?
Well, I'll say what we're seeing with customers now is that they're using JPEG XS as a way of compressing video to successfully get it into and out of the cloud. Within the cloud, we actually have some new technologies called the Cloud Digital Interface, which allow us to successfully move uncompressed video in a reliable fashion from point to point within the cloud. The challenge is ST2110-20, as developed, was great for single tenant networks where there was well engineered for specific media applications. The cloud is a more general world, right? Where it's a much larger network, it's multi-tenant, switches are being taken in and out of service all the time for maintenance, there are occasional congestion hotspots. Your normal TCP flows have no problem dealing with the situation. But if you're depending on UDP flows to absolutely positively never have packet loss, that's not going to work out, because 99.99% of the time it'll be fine, but then there may be occasional packet loss. The Cloud Digital Interface, which is an open specification developed by AWS, which is available on GitHub, is a way of trying to move uncompressed media through cloud. We implement it using the Scalable Reliable Datagram protocol, which is a novel protocol designed to move uncompressed media reliably through large cloud networks. But JPEG XS, becoming, I think, very important for moving onto and off of the cloud. And also, it's obviously part of now SMPTE 2110 via the SMPTE 2110-22 standard, which allows the use of constant bitrate compression systems as long as they have an RTP payload defined, like JPEG XS.
That's very interesting. So, John, I was noticing on the Imagine Communications website that you've already supported over 200 SMPTE 2110 deployments, which is absolutely incredibly and fantastic news. What are the pieces of the 2110 workflow that you've been supporting over the last few years?
So I'll say, like our colleagues at Grass and at Evertz and other places, we've implemented 2110 into every product we make. So into the multi-viewers, into the processors, it's mainly our focus these days, and of course on the playout systems. So as we roll out new playout systems, if they're ground-based, most customers now deploy it as a 2110 environment, and that's very common. As Thomas mentioned, others mentioned, 2110 uncompressed in its original flavor was really about breaking the packaging of SDI and saying, look, let's get back to treating video and audio and the ancillary bits as first-class citizens and being able to mix and match. And in production environments, that's really important. In playout environments, it's useful, but it's not maybe a headline feature in the same way. A lot of people ask, why can't we just use 2110 in the cloud? And the answer is, well, because there's more appropriate technologies. 2110 uncompressed was designed around the notion of, like we said, a network that you're in more control of, like a premises network. When you're in the data center operator is in tremendous control of their network. But so much so that, like in the AWS case, they have this CDI technique that's built totally appropriately to their data center design. And so we use it, and that everyone should, right? That's in each case, in each network you're on, you should use the most appropriate transport. Now, that said, we see JPEG XS as a great solution operating point for going from ground to cloud, and frankly, from ground to ground between facilities as well. It's a nice trade-off of bit rate and complexity and so forth for getting things from here to there, ground to cloud, cloud to ground. And that's one of the very active working groups I think all of us are involved in, is how do we come up with the common technical recommendations of how those things all interoperate.
Sure. So that kind of leads to maybe a more general and open panel question here is noting the success we've had with SDI and how well that made it, the possibilities that it gave us to interconnect so many different people's equipment together. Where are we today with SMPTE 2110 infrastructure? Who's making the transitions now? And have any of the barriers to entry been removed, and what barriers still exist? Robert, do you want to maybe take that one on first?
I love the way technology advances. When John and I and some other people in this industry 5-6 years ago first started doing IP networks, the switches were $130,000 a piece. To do an entire 2110 system of any scale, you couldn't even get in the door for less than $1 million. Now we have 6-7 years of maturity underneath us, and we're starting to see the cost of 2110 meet parity of SDI routers at a pretty small area. If somebody comes to me and says, Robert, I need to build a system 200 squared, we're to the point now where IP is about the same price as doing that in SDI. 3 years ago, that was an 1152 squared system. 6 years ago, it was significantly larger than that. So, the biggest barrier of entry was traditionally cost. It was you had to buy some big switches. You had to have a bunch of staff that really, really knew their stuff on the switches and on being able to control flows and multicast and things like that. The cost has finally come down. Now that vendors are supporting it natively, now that we're no longer having to buy $500,000 or $1 million a gateway to bring a facility online, that was a huge part, is not having to buy these gateways anymore, was huge. And I think seeing stuff come out of the switch manufacturers between Mellanox and Arista and Cisco and so forth, where we're seeing switches come in now that can handle, almost 100% load, which is what we need for SMPTE 2110, down in the like $15,000, $20,000, $30,000 range, has been really huge. The last part I think is just the industry's matured. We're starting as an industry, we're starting to offer tool sets to the engineers that you no longer have to have a broadcast engineer that has a CCNA or even something more exotic than that just to manage the network. The broadcast equipment manufacturers are starting to provide SDM tools and SDM tool sets that make it easy to plug devices in, easy to configure the devices, easy to manage the flows, easy to diagnose the flows. It's just the maturity of the industry as a whole. So I think a lot of those main barrier of entries are starting to finally crumble, and we're starting to see a rapid evolution of it.
Excellent. So I know that Cobalt makes lots of glue pieces, and that's kind of one of your specialties, is solving problems in between devices. Where do you see things at today? What barriers do you see that we still have to conquer?
Well, as you pointed out, we make the glue pieces, right? And we are actually working into adding more to that and kind of moving on into the ecosystem. The barriers, the difficulty at this point is more of the control side, right? There was a price barrier, as Robert indicated. Now it's coming down. You can at least afford to buy the pieces and hook them up. But once you hook them up, configuring them, getting the flows to go it's still a little bit of the challenge. So that's where our customers see the problems, right? That's basically I'm telling you what the support calls is about, right? Yeah, this thing don't work, or how can I make this go over there? So that's the next step, and we're working on that. And this NMOS business is a step in the right direction. It's making that more prevalent and making it easier for the customers or the users to basically make it work, make the flows go. That's really that's what I see here.
Okay, John, maybe you can tell us a little bit about some of the folks that you see that are making the transition now. What is it that what barriers have they overcome to make it possible for it to be an effective install for them?
Oh, I think in every 2110 project, just like in any project, the control is really where it comes down to. So, we did a lot of good work over the last 4 or 5 years as an industry doing interop events of 2110. So everyone brought their hardware to Houston or wherever it was, and we plugged it all together. And at the signal level, 2110 interoperability has been fine. I would say that that's not an industry problem anymore. I confidently believe you can take video, audio, ANS data from any two rational vendors' stuff, plug them together and get them working. Now, at the control layer, that's where the AMWA NMOS really has come to the fore in the last few years. And it's also something that when it's implemented, when people actually take the time and effort, and most major vendors, by the way, do, then you can also plug together. So a great customer example, recently, I think it was last fall, we put up TV 2000 in Rome as a great example of, Sony switchers, Sony cameras, Imagine infrastructure, some audio stuff from different audio vendors. It's all strung together with NMOS as the control layer. So we didn't have to go write a custom driver for the Sony switcher, custom driver for this or that. We were able to actually use NMOS for the, interconnection of stuff from different vendors. And that evolution is as important as 2110 itself, the ability to have a common control protocol that really works in a common way. I think that's what helps move the industry forward. So in the same way that AWS now has CDI as a signal format between instances, equally there's some common APIs to how you use it. And that's a equally important thing. So one of the work items that's going on right now in the VSF is on the control layer of how does a ground launcher and a cloud catcher actually find each other and know about each other's signals? How do we make sure that a customer can send their signal from their plant to their instance in the cloud and have the two be organized in a secure manner, in a controlled manner?
Yeah.
So, the ability as an industry to have these control protocols and have them in an organized way is ultimately as important as the signals themselves, and it's what's pacing all new projects. So I'm glad that NMOS has come into a level of maturity that we can all use it without worrying about it.
Excellent. I think that's fantastic. The ability to have devices not only talk well to each other and exchange their information, but be able to control each other and behave as we would have them behave is fantastic. Thomas, you've been involved with NMOS and as a real user in some of your previous lives. Maybe you can address some of those barriers and how effective that has been in moving 2110 and this whole new technology forward.
Yeah, well, NMOS definitely brings a level of sanity to trying to deploy and operate an IP-based broadcast system. And, I think a lot of the progress was made by the Advanced Media Workflow Association in their many workshops. And, we recognized even before COVID that it was challenging to make people travel halfway around the world to some specific location to plug in their devices just to exercise a fairly low bit rate RESTful API. So we developed a virtual workshop mechanism where a soft ether VPN running on AWS, by the way, was set up in order that the participants could just connect to the VPN with their devices or their controllers, and they could try to talk to one another and try to work out a lot of the interoperability issues with AMWA and NMOS, and we're able to solve those and successfully show interoperation. So, I really want to give credit to those who put in so much effort into these AMWA NMOS workshops to make NMOS work well between multiple vendors. They did a great job.
Excellent. So that kind of takes me to another one that is directly directed right at COVID. Cloud-based workstations using PCOIP and low-cost bandwidth video transmission has become the norm thanks to COVID forcing us to work from home. Business teleconferencing tools, smartphone cameras, and webcams are in routine use at home, in at-home scenarios for both production crew and on-air talent. ST2110 was not initially designed for this. How is it adapting to remote production workflows developed during the pandemic?
I think that ultimately the workflow evolves to meet the constraint set that's involved. So it's not about saying, was 2110-20 or was 2110 uncompressed evolved, as much as saying, how did we find the right bit rate and the right network connectivity to do the job in the constraints? So frankly, a lot of very low bit rate stuff happened. It's not JPEG XS, it's not uncompressed, it's good old H.264 really is what's carrying all these shows and carrying the multi-viewers back to where the talent is, carrying the previews to where the director is, so forth. It's not we're talking about new work and new futures and how to do sort of, very high level production grade stuff in the cloud. And that's important. And that's what we're going to do a lot more of in the future. But if you look at the things that we've lashed up over the last year to get through the urgency, it's been a fair bit of lower rate work, at a lower bit rate work. It's all good television, right? It's again about using the technologies at hand, the whole set of them, to meet the constraint set on the table. So for the networks that we can get to people's homes in different parts of the US, which are surprisingly good in many parts of the country, we are able to leverage, a lot of H.264, a lot of technologies like RIST, frankly, at these low rates where they can overcome the packet loss profile of the consumer internet.
Yes.
Yeah.
RIST is the ideal solution for that kind of stuff. RIST and technologies like RIST, because you're not going to get a gigabit per second or 500 megabits per second from your typical house, right? And many times what you have is a cell phone, and you push those technologies in there and you ingest that, and then it comes into your workflow and you just deal with it.
Yeah, one of the popular devices that we've been selling to many customers looking for remote workflows is the Elemental Link device. It's just a little yellow box. You sit down, you put SDI into it and an internet connection, and it connects to the cloud, and using H.264. It's really horses for courses, which is a British term I really like. There are times when high latency H.264 streams gets the job done fine. We've got customers who like using NDI. which is a lower latency proprietary protocol. We have customers who like using JPEG XS to get things onto the cloud as well. There are other folks who are using even 2110-20 uncompressed in the WAN, such as the Andrews Hub. So you can even do that as well if you like uncompressed. I think it really depends on what the value of the content is, what your latency and quality requirements are. And there are all these different tool sets which you can use. So I'll say I am a big fan of RIST, having come up with the acronym. That was my complete single value to the project, right? It was really Rick Ackerman's who did most of the hard work of bringing people together on and putting RIST as a specification out of the Video Services Forum. I'll say though, SRT is it's a proprietary yet open protocol, but it's one that folks seem to like as well. And Zixi also does a great job, especially for getting through challenging firewall situations. Elemental Media Connect supports all of these different protocols. Definitely there are many different ways of doing this, and I think you just have to think about what the specific requirements are for your particular workflow and come up with the right protocols and compression or not mechanisms to use.
Excellent. Robert, I know that Grass Valley has a substantial remote production product offering that has been recently introduced. Can you tell us a little bit about what impact 2110 has had on its release and its success? It's a direct correlation, honestly. I like the fact that Thomas just started talking about Zixi and SRT in addition to RIST, in addition to 2110 WAN and JPEG XS. At one point when we finally got a pretty good engineering and industry consensus behind a single standard for doing IP, then all of a sudden we now have 6 new ones. And I like that though. And I think that's a really good thing because those individual things have all come to be because of workflows that required it. And there was a need that wasn't answered yet. So for us on our Grass Valley AMP platform, and for those who don't know what AMP is, that's the ability to take a Grass Valley switcher and use it in an AWS or Azure environment, or do multi-viewers in AWS or Azure. Basically anything that's public or private cloud, we're starting to take all those individual bits of productions between switchers and multi-viewers and processing, up, down, cross, convert, HDR, convert, all that kind of stuff, and treat them as processing nodes in a public or private cloud environment, or a public or private data center environment. And 2110 obviously plays a big role because we do have to have a connect from customers' existing workflows into the cloud environment. How do we take the thousands of workflow or thousands of sources that are in their local environment, or in this case, multiple environments, and bridge that into an AWS or Azure type of platform? So 2110 for us has been really a fantastic workflow to work with because it eventually gives you a common bus of which you can reach all the sources. So as long as your encoders have enough bandwidth to get into the Cisco core, your encoders can basically grab a source from anywhere they need, regardless of where that source is, as long as there's enough relative bandwidth to get it. And then, whether you're using the Grass Valley boxes to send them up to the cloud, or whether you're using Zixi or SRT or things like that, at that point doesn't necessarily matter. So again, 2110 has been absolutely key for connecting existing environments into the cloud, especially for our production workflows. But I think some of the work we're seeing with 2110 for the WAN environments, and even some customers now using a direct connect into AWS or direct connect into Azure, are starting to talk about taking 2110 workflows, which are usually UDP multicast, and starting to encapsulate them as unicast and starting to play with all sorts of new things. And this is what I love about the last year. And it sounds so weird to say that, yeah, there's something good that came from this. I would say it's a minor good, but there's been engineers the past 5 or 10 years in this industry that had said, hey, this would be really cool if we did this, or we should try this. But due to kind of a more conservative broadcast engineering environment, it's always been, no, we're just going to do what works. So in this last year, we've had to go with, yeah, what we've done doesn't work. So who's got some great ideas? And I think that's probably one of the biggest changes we're going to see in broadcast. Isn't just the tool sets are here, especially with 2110, and being able to bridge that into a cloud environment, but it's the engineering mindset of who's got a weird idea that just may work, and let's test it and find out.
because we haven't had that too much in our industry, and it's great to see.
Excellent. So before we launch into the open questions from our participants, I have one more that we'll just throw out there for everybody to answer. What advice would you give to broadcast customers looking to adopt 2110? Where do they start? What will keep them from making mistakes in their design and deployments?
I'll just throw it on there. I know all of us have got a ton of experience, so we can all build off of it. I think capture as much data about your workflow as possible. Let's just take a look at a myopic part of audio, 2110-30. What are the capabilities of your transmitters? What are the capabilities of your receivers? If your transmitters are only 2110-30 level A 8 channels, but your receivers are level A 4 channels, but they support 2 of them, how are we going to fix that delta? Or some vendors just went off and did level C and said, we're not going to worry about the standard. We like level C, so this is what we're going to do. That's one small case of, you need to see what your transmitters are capable of, what your receivers are capable of, and if there's a delta, what can you do to remediate that delta? So, capture as much data about your workflows, your devices, your flows, your senders, receivers, and so forth. That'll save you a ton of headache in the future.
Great.
Yeah,
Thomas?
I'd build on that. I'd say the get the data about what the devices you like can do, and very much don't get fascinated by some crazy little feature. Like I've seen customers sometimes try to cost optimize the wrong thing. They think, oh, I'm gonna, do everything sideways in this really funny way because then I can save 3 SFPs over in this one link. And really, your goal is to make a system that is straightforward to own and to operate. Ultimately, the cost of the IT industry parts of these systems, meaning the switches, the SFPs, the optics, the fibers, that stuff has come down and continues to come down in cost tremendously year over year over year. So if you're sitting here in early 2021 planning a project that's going to be implemented in, say, late 2022, don't take today's cost of a 100 gigabit SFP to be an engineering concern about a project you're going to do 18 months from now. Because chances are that SFP is going to have a completely different cost point 18 months from now, almost for sure. And the same is true of computing infrastructure. If you're talking about blades and blade servers and processors, once we're using stuff from the IT industry, remember that it all lives on the IT industry's price curve. So it's very important to keep in mind that the costs of the parts that come from the IT industry will keep coming down and keep, evolving down over time at this really predictable, almost like there's a Moore's Law kind of name to that curve. It's not quite on the Moore's Law slope, but it's close.
Yeah, I'm going to say something obvious, right? You start with what do you want to do, not what is that box doing, that other box doing, how I connect this box. Start with what you want to do. Many times a customer comes and says, how do I do B? Because they thought, okay, I want to do A, and the way to do A is B, and they come to me and ask, how do I do B? And you have to go back and say, no, what is it that you actually want to do? So have a good picture of that and go from there.
Right, and I always hate to have to remind television customers of this because it should be kind of an obvious statement, but fundamentally, content creation is a creative profession done by people whose job it is to create content. And we have to really look at it through the lens of how do we help them, how do we enable them, how do we give them the tool set they need to do their job. And the rest of it is really a supporting role where we're managing risk and we're managing availability, and fundamentally we're managing the number of creative people that it takes to do a creative job. So to Ciro's point, it's really about understanding what is the human workflow going to be? What does the content creator need to see? What do they need for a control surface to interact with that? what information do they need to make good decisions about it in a playout, or say an operations sense where they have to choose whether to cut away, whether to stay with that scene, whatever it is. You design the facility to do, or design around the people who have to make the content, and then work backward to, okay, how does the technology support that?
Great.
I think we have reached a great level of maturity in SMPTE 2110 systems, and there's a reason why SMPTE 2110, or specifically SMPTE and VSF, will win an Emmy Award this year for SMPTE 2110. It's very relevant and makes a lot of sense, and almost every large plant that's being built now is 2110. But I do think it is important to keep in mind your complete end-to-end workflow. And something that customers are telling us is that the value of their media is maximized the faster they get it into the cloud, because once it gets into the cloud, there's a wide range of scalable processes that you can do, including transcoding. You can do analysis, including extracting metadata using artificial intelligence and machine learning. You can easily hand off content from a content provider to a content distributor on the cloud. So do think about, even if you're moving at uncompressed 2110-20 inside your plant, do think about how you can rapidly get that on the cloud to get the scalable and elastic benefits of cloud-based processing.
Fantastic. Well, this has been great, guys, so far. I think it's time now for us to turn it over to our audience, and let's take some questions from them. Before we get to the audience to consider for your SMPTE infrastructure, Cobalt Digital. Cobalt is known for their throwdown single-channel gateways, dual-channel multi-rate reclocking DAs, and up-down cross-convert frame sync solutions. The Cobalt 9904 UDX 4K IP 12G, 6G, 3G, HD, SD, UHD up-down cross-converter frame sync with dual 10 gig IP ports is Cobalt's next generation of advanced scalar frame synchronizers for the OpenGear platform. The 9904 UDX 4K IP upconverts 12G, 6G, 3G, HD, SD to either UHD1 3840 by 2160 square division multiplex or two sample interleave 2 SDI quad 3 gig SDI based formats, or can output ST2082 12 gig SDI for single wire 4K transport. With both 12 gig SDI and quad 3 gig SDI inputs, the 9904 UDX 4K can downconvert 12 gig and quad UHD. Grass Valley. Grass Valley has quite a few cameras supporting the SMPTE 2110 standard. Their latest LEX 100 series uses a new 2/3 inch Titan imager to capture ultra high definition and high dynamic range images at 3 times high speed. It also supports JPEG XS. Imagine Communications. Imagine Communications has a variety of SMPTE 2110 pieces of an end-to-end workflow. SDI to IP, IP to IP, broadcast router control, multi-viewers, playout, master control, ingest, transcode, and encode to delivery. Today, we're highlighting the Selenium Network Processor with production multi-viewer personality, the SNP-MV. Integrating with industry standard Tally, UMD, and routing protocols, including NMOS IS 04/05, the SNP-MV delivers enhanced production agility through low latency operator interaction with HDR or SDR and a lot of customization and flexibility built in. AWS, Amazon Elemental Live Encoder. AWS Elemental Live supports ingest and output of SMPTE 2110 video, audio, and ancillary data using a 10 gigabit or higher Ethernet network card installed on your appliance. It's the perfect solution for a deploy anywhere, deliver anywhere encoding solution, processing video in real time, delivering to a variety of television and internet connected devices. Some other partner solutions that we would like to highlight include Telestream. Telestream's Inspect 2110 monitors ST2110 IP video networks, providing the automated visibility and diagnostics operations teams need. Broadcast production is changing from SDI to IP video, bringing several benefits in flexibility, scale, and efficiency. Make sure everything is working before you go live. Matrox. Vero is an essential tool for broadcasters, system integrators, and manufacturers of ST2110 devices and environments. Matrix Vero integrates the components required to allow users to confidently validate ST2110 devices for compliance before deployment. Arista. Arista Networks is the gold standard in the industry for broadcast, over-the-top, and streaming media network infrastructures. Their products include tools such as real-time analytics, scalable multicast, and scalable PTP, the three pillars for any successful standardized SMPTE 2110 deployment. And with open APIs for broadcast controllers such as Imagin's Magellan or Grass Valley's Orbit, Arista enables tight integration with system orchestration that is feature-rich and bug-free. Available in sizes from 48 ports of 1 gigabit per second to 512 ports of 400 gigabits per second. So we're back here live to answer a few questions. Well, we've got some great questions that have come in already. Please be sure to get your questions in as soon as possible. And any questions we're not able to answer during this period, we'll be happy to try and get you responses from our panelists later on. Our first question comes from Robert. What are the key characteristics of a network switch required to support SMPTE 2110? And are there specific ones required by GV or Imagine or other manufacturers?
That's a good question. The whole beauty of using commercial off-the-shelf switch technology is that you have multiple vendors to choose from. So it's important that the switches support PTP. It's important that they have enough internal bandwidth, meaning they aren't, some funny switch that's got, blocking inside. But most of the real good switches of, Nexus 9K family, Arista, 7800 or 7280 family, things like that, meet all the requirements. So there are multiple vendors that make them, and it's good for customers to have choices.
Excellent. And here's another question from Ed. Is NMOS working now, and where is it implemented?
I guess I'll jump on that one. NMOS is working really, really well right now. ISO 4 and ISO 5 is really quite fantastic. And to give you a really good real-world example, there's a university recently that we've been working with that has Imagine SMPs. They have a Evert stream catcher replay system, Grass Valley switchers, Cisco switches, and we put them all under Grass Valley Orbit control. The best part about that is when we brought the control system online, the SMPs and the dream catchers and the switcher just popped up in the ISO 4 repository as saying, hey, we're here. It registered with the system. It gave us all its SDP data. And then via ISO 5, we're able to start creating and destructing flows to it. It's literally exactly how it's supposed to work. And, it's taken us a couple of years to get here, but we're definitely seeing the maturity now of ISO 4 and ISO 5 on devices. It truly is getting to that point where you plug in the devices, they register, and now you can control them over ISO 5. So the maturity's there. The efforts of JT&M and stuff to get us there is fantastic. All the interop sessions has been fantastic, and it's really paying off dividends now.
Yeah, we've seen the same thing in the field that, SMP is being successfully controlled by Orbit, by the Sony LSM, by the Nevion controller, by Cerebrum, of course, by our own SDNO as well. And in the same way, our SDNO control system is controlling Sony switchers and Sony cameras and all manner of audio equipment through ISO 4 and 5. It's really gotten to where if we integrate with the device that we haven't integrated before, and we ask, does it do NMOS? The answer winds up usually being yes. And during commissioning, it generally works. The exceptions are rare at this point.
It's good to know. I've got another one here on routing. It says, this is from Rod. It says, is multi-level routing easily done in a 2110 workflow?
Yeah, multi-level, we're talking video, audio, metadata, like, yes. I mean, that's kind of what 21 standard was designed around. Mm-hmm. So there is no major issues. We talked about this a little bit earlier in the session. It's also mainly just gathering enough data when you design the system, because multi-level audio or multi-level routing usually incorporates audio. And again, we already kind of talked on this a little bit, but just capture the requirements of the audio senders and receivers to make sure that the sender isn't, 4 chunks of 4 channel and the receiver is expecting 1 of 16 or something. if you capture the data and you prepare for it, there is no issues at all with multi-level routing.
Okay.
In fact, one of the collateral challenges or benefits we run into is frequently people have an existing sort of SDI router that they've controlled in a one-level mindset for years. They roll in something 2110, it's inherently a multi-level system, which means all of their, tally systems and other things have to suddenly do something more complicated. So a technique we use frequently is to do protocol remapping, where to those northbound systems, things will look like a single level, but that single level appearance is really a multi-level take under the hood. And so that way, we can sort of ease the integration pain of having to suddenly have multi-level routing where maybe not everything in your plant cared or was expecting it.
Right.
But to Robert's point, it's critical to identify early on all the equipment you're going to use, how it expects the 2110 audio to be organized, and then do that pre-planning so that the system works the way you expect afterward.
Okay. Here's another one. How important is PTP SMPTE 2059-2 to SMPTE 2110 implementations?
Pretty important. I mean, yes. You could use PTP without the 2059 TLVs and you'd probably get it working. But if equipment's trying to generate time code or participate in something like JAM, in the 2997 systems, it's really important to have the TLVs. In the 25 hertz world, maybe you could get away with it, although Whitcomb will yell at me later about that.
Okay. Here's an interesting one. Does AWS support multicast in PTP in VPC?
Multicast through the transit gateway system. However, I will mention we're not recommending that for media flows right now. It's probably more appropriate for multicast control signals and things along those lines. So yes, but I think for most of the media flows that we're looking at, we still want to stick with unicast flows within the cloud, either using things like SRT, RIST, 2022-7 redundancy, or the other option is using CDI, which is a very different way of reliably moving media streams through cloud.
I have kind of a combined question here on monitoring. Do we have monitoring devices for 2110? Can you name some of them, and how do we handle it in the cloud?
So, I mean, on the ground monitoring, Tech Prism, Bridge Tech makes a nice unit, Fabrics makes a nice unit, Leader makes a nice unit. There's no shortage of test equipment for 2110, and most of it's quite good. So, and most of them speak NMOS too.
That's the part I was going to catch is just in the last year or so, we've seen almost all of them implement ISO 4 and ISO 5 because there's nothing more annoying than you're trying to diagnose a problem, trying to send a flow to a piece of test gear that you have to manually put in multicast IP addresses or something. So having them adopt ISO 4 and ISO 5 over the last year, at least for on-prem, has just made it an absolute dream.
So here's one that's kind of a common theme. This is from Robert. He says, I have worked where equipment is used and still supported literally for decades. The IT industry has always had shorter life cycles and early end of lives and broadcasts. Do you see the longevity of installed plants being much shorter than in the past?
I don't see that, because we are broadcasters. We are vendors for broadcast systems. So once you put something out there, you need to support it for a decent amount of time. So yes, the IT industry is moving, and the PC that you bought 2 years ago is end of life already in the switch. But on the broadcast, if you're a credible player like the people in this panel, yes, will be supported for a decent amount of time.
And added on to that just a little bit too is, especially for the 2110 flows, we're usually using enterprise grade switches, and enterprise grade switches tend to have LTS, or longer term support, than some of your just standard off the shelf stuff where they have it and a year later it's gone and that kind of stuff. So on the enterprise side, you do tend to get more life cycle, and that's one important thing to talk about is, we're not using a $100 switch or a $500 switch here. So, the usual amortization of 2 years or 3 years of IT is kind of out the window on the broadcast side.
Yeah, and just remember that this 2110 stuff, this is the last piece of the broadcast plant to move into IT. You know, everything in your playout servers and storage arrays and all that stuff, you've been dealing with IT equipment now for quite a few years. And so, you know, as Robert says, I mean, it's enterprise grade equipment, it's on enterprise maintenance schedules, and generally, you know, you're getting a product that will have a reasonable lifespan.
And 2110 gives you some of the highest quality, lowest latency streams available. But the truth is that there are lots of workloads which are moving onto the cloud for media and entertainment. File-based play out of linear channels. There are thousands of channels playing out on the cloud right now. So many of these workloads that you may have done on premises in the past will be moving on to the cloud, and you might find that in the next couple of years, the only things you want to keep on premises are the highest quality, lowest latency requirements for hard live production. But again, even that will be, I believe, will be beginning to be moving into the cloud soon. So I think we also have to consider that the data center that you've built for broadcast today, it may be a lot smaller in 5 years. It might not even exist at all in 10 years.
Excellent. Here's an interesting one. Are there any auto discovery of devices on SMPTE 2110?
Yes.
See the previous conversation about NMOS. Yeah, a correctly designed device turns up in the registry, and you go in your routing control system and say, that one, call it this, map it in.
There we go. Here's one from Phil, dealing with some compression. It says that now that 2110 supports compressed workflows, what are the best practices architecturally speaking? Do you keep compressed and uncompressed as separate as possible, or do you mix them?
I don't see any reason to split them up aside from maybe WAN applications. If you're doing it for a LAN application, it's literally just a 2110-20 for uncompressed and 2110-22 for your compressed flows. You associate them correctly in your control system and you go on your way. Again, it's not until you get to WAN where you really want to start breaking those out to separate them. But the nice part about using compression is largely it's an order of magnitude less bandwidth. And so if your system's already built for uncompressed, being able to do that on the -22 flows, it's not really that much of a consideration.
Okay.
Yeah. And when you get compressed, then things like using the internet or using lower bandwidth WAN links become available, and that's what you're looking at for that.
Okay. So this is one that I think lots of people have on their mind. 2110 makes great sense when you're building from scratch. At what point does it make sense to start transitioning to 2110 if you are currently heavily invested in SDI?
As a vendor that manufactures a lot of the endpoints, I'm just going to put on the vendor hat just for a second, is most products that we sell, and I can almost say almost every other vendor out there supports SDI and IP today. So we like to tell customers, buy product. If you think you're going to be going on IP in the future, which everybody should be planning on that at this point, plan on products that can support SDI or can migrate to IP. Most products can. You may pay a little bit of a premium for that ability to start SDI and then go to IP, but largely that premium's worth it if you look at it in the long term. So it's something that can be planned around. We're seeing customers who did SDI facilities 2 or 3 years ago already starting to look into IP today. It's the reality of the industry as it is. So if you buy your products with the capability of doing both, again, you'll pay a premium, but long term, it's worth it.
I think as we see more virtualized and software-based media processing solutions come on board, I think that the move from SDI to IP is going to become more important for a lot of folks. In that, it's one thing if you're saying, well, I'm going to switch one cable for another cable, but it's another thing if you're saying I'm now going to be moving into a completely IT infrastructure where I'll have virtual machines being spun up and spun down to do different processes. So I think that's going to be, I think, a big mover for people who maybe have existing SDI investments, and once they have this opportunity to go more virtual, I think they'll take it.
Okay. I think we got time for about one more question here. Let's get down to this last one. Let's see. Building a system with 2110 environment, what are the bandwidth challenges with the amount of data that is passing through the switches and system?
You know, you just have to do the math, right? Every HD signal is about 1.2 gigabits. Every UHD signal in 5994 world is about 10 gigabits. And so, you know, you buy the switches with the right number of ports and speeds to do the job you're doing. It's just an engineering exercise.
Bandwidth just needs to be there, man.
This goes
Add it up.
This goes back to the theme that we've all been talking about this whole time. It's just the amount of pre-planning you have to do. It's, you know, instead of counting SDI ports, now you're just treating everything as a function of bandwidth. So the more data you can learn on or you can gather on the front end will absolutely save you from having to consider any of this in the back.
Yeah, I mean, 1152 is no longer the magic number, but there is a magic number, but it's a much bigger number.
probably beyond what you would need ever really need to use.
Yeah, well, the truth is, you know, there are only so many huge video installations in the world, right? There are a lot of much smaller operations, and for them, there are plenty of switches. You can buy a single switch; it'll be non-blocking for, you know, hundreds of channels, and that's all you're ever really going to need.
Right. Well, it looks like we are completely out of time. I really want to thank Robert, Ciro, Edward, and John for joining us for this event today. If anyone who's watching has any more questions about SMPTE workflows, please feel free to contact the KeyCode Media team. We'd be happy to schedule a follow-up with you. Also, don't forget to subscribe to our newsletter and our YouTube channel. We'll continue to create great content like this every month. Thanks again for joining us today from all of us here at KeyCode.